Hi, in this video I'll show you how to find that if the two matrices A and B are inverses to each other, and after that we will find the inverse of A. So to prove that A and B are inverse to each other, we have to prove that their product is equal to the matrix identity, which is 1 0 0 1. Remember that the identity matrix is in this order 1 0 0 1. So we need to prove that A times B is equal to 1 0 0 1, and also we have to prove that B times A also is equal to 1 0 0 1. So this is B times A. So now if we multiply A times B and we got different than 1 0 0 1, so no need to continue, and we'll say that these are the two inverses are not the two matrices are not inverses. But if we got it 1 0 0 1, so we have to perform also B times A to prove that, to see that if it's equal to 1 0 0 1. So let's perform the multiplication A times B. So A times B would be, let's write A 3 4 minus 1 minus 2 multiplied by B, which is 1 minus 3 2 4, and then we find if they are equal and the product is equal to 1 0 0 1. So it's equal to, let's see, multiply. So as we mentioned in previous video, the product, we multiply the first row by both columns. First of all, we do the first one with the first column, then we do the first row with the second column, and then we move for the second row to perform the same process. So performing the first multiplication, we say 3 times 1 is 3, and minus 1 times 2 is minus 2. We put plus between them, and here we have minus 2. So 3 times minus 3, we get minus 9, plus, and then minus 1 times 4 is minus 4. I did with 1, 2, and then I did with minus 3, 4. We do the same process with the second row. We multiply 4 by 1 is 4, plus minus 2 times 2, which is minus 4. And the same thing we do it with the second column. So 4 times minus 3 is minus 12. And 2 times 4, sorry, minus 2 times 4 is minus 8. So we say that it's equal to, and we do the addition. 3 plus minus 2 is 1. Minus 9 minus 4 is minus 13. And 4 plus minus 4 is 0. But minus 2 and minus 8 is minus 20. So in this case, we don't have 1 0 0 1. So we say that they are not inverses. And in this case, we don't need to perform the B times A. Why? Because already we deduced that the product doesn't equal to the identity matrix, so the two matrices are not inverses to each other. Now, to find the inverse of matrix A is equal to 3, 4, minus 1, minus 2. And we want to find the inverse of this matrix first. To find the inverse of this matrix, we have 2 or 3 steps to follow, and then finally we can find the inverse. First of all, we have to find the determinant of A. To find the determinant of A, we write the numbers 3, minus 1, 4, and minus 2 in a determinant, and we perform the calculation of the determinant. But let me show you. We multiply cross. We multiply 3 by minus 2, 3 by minus 2, and we subtract this product from the other product. 4 times minus 1. We do 4 times minus 1. So if we repeat it again, we say 3 times minus 2 minus, this is a rule. So the minus is for the rule. And then we put the other numbers. 4 times minus 1, which is here. So we calculated 3 times minus 2 is minus 6, minus 4 times minus 1 is minus 4, and we have minus, so it becomes plus 4. So final answer is minus 6 plus 4 is minus 2. So here is the determinant of A. So to find now the inverse, the A inverse, we have to put A inverse equals to 1 divided by the determinant. Let me write it here. 1 over the determinant of A. And we put the new matrix, and I'll show you how do we arrange this. So first we put 1 over the determinant, which is 1 over negative 2. That's negative 2. And we open a new matrix, and that new matrix, it has also different arrangement. Look at that. I'll show you like slowly, and then you need to memorize those two steps. So 3 and minus 2, we just flip the numbers. We don't do anything else. We don't change the signs. We don't do other things. Just flip the numbers. Minus 2 will take place instead of 3, and 3 will take the place of minus 2. So we write minus 2 here, and we write 3 in the place of minus 2. With respect to 4 and minus 1, we leave them, okay, but we change their signs. What do I mean by that? Like 4 becomes minus 4, and minus 1 becomes plus 1. So we change their signs. Whatever the sign is, we change it. If it's minus, we make it plus. If it's plus, we make it minus. So here we have minus 1, we put plus 1. 4, we have plus 4, so it becomes minus 4. Now, we can perform the calculation. So we multiply the number outside the matrix by all numbers inside the matrix. So minus 1 over 2, we multiply it by negative 2. You get minus 2 over minus 2, which is 1. We multiply 1 times minus 1 over 2, you get minus 1 over 2. We multiply minus 4 by 1 over minus 2, which is minus 4 over minus 2, which is 2. And we multiply 3 by 1 over minus 2, which is minus 3 over 2. So we have fractions. It doesn't make any problem, but at least know that you multiply the 1 over the determinant, the number we got it outside, by all numbers inside, by everything, not only by only row or column or numbers inside we have to multiply it by everything inside. So this would be the inverse of A. So A minus 1 and A, these are inverses of each other. If you multiply these two matrices together, sure, you have to get 1, 0, 0, 1. And you can perform that yourself, and you can check it. If you multiply A by A minus 1, which is this, their product should be equal to 1, 0, 0, 1. And then this will prove for you that these two matrices are inverses to each other.